Here we have what I said was a standard form for the ellipse. Do you recall how the hyperbola is different? Just the sign. So we're going to start from the most general form and go forward with this one. So, okay. Actually, I'm not going to ask you to do that one from scratch. I'm just going to give it to you in standard form, and we're going to graph it as from there. Alright, if I want you to start the hyperbola from standard form and from general form, I will review that tomorrow night. Alright, this is the only one I have prepared for right now. Alright, so this is a hyperbola. You can tell because the x squared term and the y squared term have opposite signs. And so we're going to go and remember what a and b tell us for the hyperbola. It's different. In fact, here's how we graphed it. For the hyperbola, we zeroed out x and found y. Then we zeroed out y and found x. So we only used a sissy chart in two parts, 2 points, and that got us all the secrets that we needed of the hyperbola. So if there was a number hooked here to y and x, we would have a center, but there's an unwritten 0, -0, and -0, so it tells us the center of this hyperbola is 0, 0. Now we need some other points. And the way we get them is we zero out x. So putting in a 0 for x, this term disappears. Multiply both sides by 9, and we get y squared equals 9. The square root of y gives me plus or minus 3 on the other side. So hopefully mentally you can see, we used to do it mentally. So you put a 0 in for y, and that creates a different scenario because of this minus sign. The minus 16 comes over here by multiplication. It is still negative, and when you take the square root of a negative number, you're going to get an I. So there's always going to be one of these that carries the I, the imaginary part. So we're going to graph those as if the I is not there. So we're going to go 0, up 3, and down 3. And we are going to go to the left 4. And to the right 4. Do you recall what we did with those points? We made a box. Those are the midpoints of the sides of a box, and the vertices connect and become diagonals, and they will form the asymptotes of our hyperbola. An asymptote is like a fence. It keeps the hyperbola in its bound. So let's go ahead then and see. So now we're pretty much done. We know it's either going to be this or it's going to be this. And I think the easiest way to tell is to look at your sissy chart, and you see this one is the imaginary one. It's not real. It's not going to be on the hyperbola. This is a real point, so this is the true answer. This is a vertical hyperbola. Alright, so this helped us get the hyperbola, but it is not on it. Alright, so we have reviewed circle, and we have reviewed ellipse and hyperbola. So I think that's enough for tonight, and we will just leave a couple little topics very, very short so you have time to study for tomorrow night. Alright, see you later.